All right, welcome to another video. This one deals with the topic of moment of force, which is also known as torque or turning effect. This is what happens when you apply a force to an object and it's able to turn or pivot around some point. Okay, so the example I have here are a couple of young men playing on what's called a seesaw or a teeter-totter. So the teeter-totter can pivot around that point in the middle, and then if you apply a force to either end, right, such as basically the weight of this boy or the weight of that boy, then the bar, the beam here, can pivot around that point and turn. All right, so probably the next thing that's going to happen is this kid is going to come down, this one will go up, and then they'll switch, and this guy will come down, and this one will go up. So that's called the turning effect. You can also make this turn with nobody on it if you just push on one side or push on the other side, right? Another example of turning would be using something like a wrench to grab onto a bolt and then you twist the handle. That's about it for that. Screwdrivers also, you're using torque or a turning effect in order to accomplish that. So this is used a lot in daily life, the effect of moments. So basically this is our definition. When a force is applied to an object at a distance from a pivot point, it will experience a turning effect, what is called a moment of force. Okay? Now here's a schematic version of moment. All right, so what you've got here is a beam with some object, let's say it's a rock on the end there, and then we're going to apply a force here where the arrow is at that angle. Okay, this is our pivot point, this triangle. Oftentimes the pivot is drawn as a triangle with the beam resting on top of that. All right, so that's our pivot point. There's a distance here between the pivot and the point where the force is acting, the line of action of the force. That distance is relevant to trying to calculate the moment. All right, so the moment of force causes a turning effect, and the force causes the turning effect. The moment of force is a measure of that turning effect. Okay, so the way that we calculate it is really quite simple. We just take force times distance, where the distance is this distance taken from the perpendicular line to the pivot point, or a line passing through the pivot point, and then straight to the line of action of the force. Okay? So since the force is acting this way, in this case, we would measure like this to the pivot. All right. Now, it's important that you go, when you're doing this measurement here, it has to be perpendicular to the line of action of the force. So if you draw a straight line in the direction of the force, then your measurement has to be perpendicular to that straight line. Like this, basically. Narrow, perpendicular. That's not the greatest drawing, but anyway. It needs to be perpendicular. All right? Cool. So, here's a different example, okay? Now we've got the force coming in from a different angle. We're going straight down now against the beam instead of coming in this way. So now the line of action of the force is this way, right? And again, the distance has to be measured perpendicular to that line and over to a line that's perpendicular to the, well, anyway, all of these lines are perpendicular. And this line here passes through the pivot point. All right, so that's how you measure your distance, like that. All right, and it all depends on what angle your force is acting at, right? Okay. So that's what we've got here. The distance to the fulcrum must be measured perpendicular to the line of action of the force. All right, so let's do an example here. We have a force of 100 newtons that is applied at a distance of 1.5 meters from the fulcrum of a lever in order to lift a stone, and we want to know what is the moment that's caused by this force F, right here. Okay, so that's the problem here. This is our D, this is our F. We're going to use the formula that we could see on the previous slide and that's the moment is equal to force times distance, so F times D in this case. And if we look back up, F is 100 newtons and D is 1.5 meters. So we're going to just plug those in. 100 newtons, and we're going to multiply that by 1.5 meters, and we get an answer of 150. Now the question becomes, what units are these? You know, we had some special units for some other things. Newtons are measured, you know, that's the unit of force. Joules are the unit of energy. Well, the unit for this is actually, there isn't any special unit, so not a special name for it. So we just call it newtons times meters. All right, so that's moments of force. That's basically what you need to know for now. We'll talk more about moments of force when we talk about the law of moments or the rule of moments later on in a later video.